Hello everyone, welcome to the course on Artificial Intelligence in Industrial and Management Engineering. Till now we are mainly covering about natural language processing, and we have covered things like lemmatization, stemming, named entity recognition, part of speech tagging, and we have also covered some tools like Spacey and NLTK. In this week we will try to cover more fundamental concepts about natural language processing, and we will try to implement some of these concepts that we have discussed using Python ecosystem. So, the agenda for this week is we will first talk about what are the broad challenges in natural language processing, then a broad overview of how conversational agents works like your Siri or Alexa. After that, we will try to understand what are the numerical representations of text and how can we transform our unstructured textual data into numerical representation, right. Then what is the different kinds of vector space models that we can utilize to create this numerical representation. Then we will delve deeper into one of the vectorizer, that is TF-IDF, term frequency and inverse document frequency vectorizer. After that, we will cover the basics of text classifications, what is it and what are the classification matrices that we can utilize to understand the quality of your model that you have built. And after that, we will also discuss about the confusion matrix, which is kind of classification matrix, and it will help us to understand our model better, right. So, let us start with the challenges in NLP. So, there are broadly 4 different kinds of challenges in NLP. The first is ambiguity. The second is context dependence. Third challenge is multilingual. Complexity. And fourth is idioms. Now, what is ambiguity? So, let us say there is a sentence, the chicken is ready to eat. So, this sentence can have multiple meanings, right. The first could be that chicken dish is ready, right. Or the second meaning of this sentence could be that the chicken is actually hungry. And is now ready to eat its meal, right. So, this kind of ambiguity in a simple sentence like this can be very challenging to address while developing your own natural language processing model, right. The second is the context dependence. So, here what happens is the meaning of the words changes based on its usage. Okay. The third is multilingual complexity, and this is simple to understand that rules differ across languages. So, the grammatical rule of developing a simple sentence in Hindi or English or Spanish will be very different, right. So, the model built for a particular language may not perform similarly for a different language. So, we need to have multilingual models for our applications, right. Other is idioms. So, it is hard for machines to interpret idioms literally, right. So, the meaning of idioms is somewhat complex, but the human mind can easily understand because it is trained to do so. But while developing a natural language model, it is not as easy as to understand idioms by the machine, right? So we need to develop focused models for idioms as well. So modern NLP uses deep learning models to overcome some of these challenges, right? So we understand what is the foundational concept of deep learning. Now these kind of models that are state of the art as of date, these can be utilized to develop better models for these kinds of challenges that we have seen in earlier classical algorithms of natural language processing, right? So now let us talk about conversational agents. So we can utilize conversational agents for speech recognition, and main components are further we can utilize this speech recognition to convert speech signals to their phonemes. And these phonemes gets transcribed as words, right? The other concept is speech synthesis, and this is nothing but the reverse process of speech recognition. So what is the natural language understanding that we can utilize? So user speech gets converted into text, and this gets analyzed using NLP system. Okay. Now here we will utilize our name entity recognition NER, and what it will do, it will identify all important entities where in the text spoken by the user. Other is the like conference resolution, identification stage. Here the automated system understands the entities spoken by the user. The next point in natural language understanding is natural language understanding. these kind of agents should understand the user's intent. Okay. So this can be understood like whether the user is asking a factual question or giving a command to the agent, right? So let's say your conversational agent like Alexa is active and you have just asked about the weather conditions outside. So this is some kind of command that you have asked, and it will go to the internet, find your locations, and then it will give you the weather of the outside world, right? But what if you just asked about a factual question? So these two commands will be tackled very differently by the device, right? So here what we can use is we can utilize the text classification algorithms to identify the type of commands, right? So we will also look at one of the applied coding. In the applied coding session, we will look at one of the example of the text classification systems, right? We will develop it. So this is how your conversational agents work, right? Now the last part is the response generation. So your agent should generate a suitable response to perform the task based on semantic interpretation. So we already talked about what is the semantics and what is the context of a simple language, any kind of language, right? So this is where your conversational agents will utilize those foundational blocks, and it will try to understand what was the semantic interpretation of your task that you have given through speech, and then it will utilize it to generate the result, and then it will give the response. Finally, an agent can use a knowledge base or utilize a template for their response. So if your command is just a factual question, then it can utilize a knowledge base from the internet, or if the response is some kind of like asking for the weather conditions, then it can utilize a template where it will only have to fill what is the current temperature or the conditions outside, and utilize a single string which it needs to repeat through its speaker, right? So that is where a template can be very useful. Now we have looked into various kinds of applied areas of natural language processing. Now let us come back to the basics of how to convert these natural language text that is unstructured into the machine language, right? So that machines can understand, because we need to create intelligent machines that can understand the unstructured text, right? So we all know that there are different kinds of recognition applications that we can perform, like image classification, where we need to recognize whether the image contains a cat or a dog, right? Or in your speech you can recognize what is the content of the speech, how the speech is changing. So, these are the different applied areas. One of the applied area is natural language understanding. Now, here the task is somewhat difficult. Why? Because the words are not directly translatable into your numerical representation. So, let us see how we can do that. So, there are different kinds of recognition applications that we can perform. One of that is image classification, right? Now, how do we represent these images numerically? So, actually the images are stored in pixels, right, and each pixel can be represented in a 2D matrix. Now, each value of this matrix will represent each pixel. So, each value I comma j represents a pixel, right. Now, with this matrix representation, we can utilize our different kinds of algorithms to perform image classification and the content of those images, right. Similarly, the next application could be video classification. Now, videos are nothing but series of frames or images, and these sequence of images can also be represented easily by utilizing matrix representation. Similarly, the third application could be speech recognition. So, this is where your conversational agents will utilize this technique of speech recognition. Now, how to do that? Speech recognition gets handled by utilizing the speech data, and this speech data is represented in the form of waves. Right. So, to convert these waves into mathematical or numerical form, what we do is mathematical representation involves tracking of the amplitude of the wave at various time intervals. Right. So, let us say this is a simple wave that gets generated after utilizing some speech data, right. So, the amplitude, that is the y value, keeps on changing with time, right. So, once we get the variations in the amplitude of this wave, we can store this into a numerical array, right, a numpy array or something like that, and we can get this numerical representation of the complete wave in by utilizing a single array. So, this is how we transform the speech data into the numerical form. Now, representing natural language data is not straightforward like these above applied areas. So, there are different steps that we need to follow while transforming our natural language data into the numerical representation of the data. So, what are these broad steps? So, first we need to break the sentence into lexemes, words or phrases, right? Then derive meaning out of these broken pieces. Each unit. The third is to understand the structure. Understand the grammatical structure. And finally, understand the context. So, the first step is to break the sentence, right? After that, derive the meaning from each unit in which you have broken the sentence. Then the other thing is grammatical structure. So, here is what the multilingual complexity comes into, right? So, if you have a different language and you have already created a model for a different language, then this grammatical structure will change for a completely new language for the same text, right? So, that is why you need to develop different kinds of models for different languages. After that, you also need to understand the context, which is very important. So, what is the actual context of the sentence or the whole document? That is the final part of your numerical representation. So, these are the broad steps that we need to perform while modeling our natural language data. So, today we will stop here and we will continue forward after to develop different kinds of numerical representation and what are the different techniques of developing these kinds of numerical representation for the natural language data. Thank you.